Every MBBS students get confused between neuromuscular transmission, myasthenia gravis, Lambert-Eaton syndrome, botulinum toxin and neostigmine. But what if I show you a single notebook that can help you remember all of them forever? Stay till the end because the last page contains the complete Viva revision sheet that can help you answer multiple university questions in less than 30 seconds. First, see the entire chapter in one glance. In the center is a neuromuscular junction. Everything in this chapter revolves around just four ideas. First one is the anatomy, then physiology, then pathology, and then the pharmacology. If you remember these four branches, the whole chapter becomes easy. Think of neuromuscular junction as a machine. Anatomy are the parts of the machine. Physiology is about how it works. Then the pathology about the glitches or the machine problems, and the pharmacology about the machine hacks. Keep this picture in your mind and every topic will connect automatically. Now let's remember the anatomy. There are only three important regions: presynaptic terminal, synaptic cleft, and the postsynaptic membrane. The presynaptic terminal contains the synaptic vesicles. The synaptic cleft contains acetylcholine enzyme, and the postsynaptic membrane has nicotinic receptors. Remember this sequence: store, gap, and catch. Store contains the synaptic vesicles, the gap having acetylcholine enzyme, and the catch having nicotinic receptors. If you remember these three words, you can draw the entire diagram in exam. This slide explains the complete transmission. Let's convert it into one simple flow. It is having two steps. Step 1 is the release of acetylcholine. When the nerve action potential arrives, it opens the voltage gated calcium channels. So the calcium rush in from the extracellular fluid and it triggers a massive exocytosis, so the acetylcholine dump into a cleft. Now the step 2 is the catch. When the acetylcholine diffuses across the cleft, it binds with the nicotinic acetylcholine receptors on junctional folds. So the tubular channels open and there is a massive influx of sodium into the muscle. That causes local positive potential, that is depolarization. The most important Viva question is, what is the trigger for acetylcholine release? Remember, calcium. Now, important these five words: action potential, calcium, acetylcholine, sodium, and contraction. If these five words stay in your memory, you can explain the complete physiology. Now comes another favorite university question: the end plate potential. End plate potential, it is local positive potential, but it is non-propagative. It simply brings the membrane close to the threshold. When the threshold is reached, that is minus 60, it triggers muscle action potential and causes muscle contraction. Now, the acetylcholine must be removed immediately. Who removes it? That is acetylcholinesterase. This happens within 1 millisecond. Remember, acetylcholine comes fast, but acetylcholine disappears even faster. Otherwise, continuous muscle contraction would occur. This comparison is extremely important. Myasthenia gravis and Lambert-Eaton syndrome. Remember, in myasthenia gravis, there is damage to the postsynaptic membrane, whereas Lambert-Eaton syndrome, the damage to the presynaptic membrane. I always remember like this. Myasthenia gravis is broken catchers, that is, the receptor is missing, while Lambert-Eaton syndrome is broken pitchers. Here the calcium can't release acetylcholine. So, in myasthenia gravis, the antibody target is postsynaptic acetylcholine receptors, whereas Lambert-Eaton syndrome, the antibody target is voltage-gated calcium channels. Acetylcholine release in myasthenia gravis is normal. In Lambert-Eaton syndrome, it is scanty or reduced. The primary effect in myasthenia gravis is inadequate end plate potential despite of normal acetylcholine release, whereas in Lambert-Eaton syndrome, inadequate end plate potential due to lack of acetylcholine. The clinical danger in myasthenia gravis is respiratory muscle paralysis, whereas in Lambert-Eaton syndrome, it is severe muscular weakness. If examiner asks only one difference between myasthenia gravis and Lambert-Eaton syndrome, immediately answer: myasthenia gravis, a receptor problem; Lambert-Eaton syndrome, calcium channel problem. Now let's hack the machine. Divide everything into only two groups: blockers and stimulators. Blockers comes in three forms. First one is the release blockers. Here, botulinum toxin, it prevents acetylcholine exocytosis. Next one is the receptor blockers. Curare, bungarotoxin, it binds to the receptors and end plate potential is prevented. And third one is depolarizing blockers. Drugs like succinylcholine acts like acetylcholine, but acetylcholinesterase can't destroy it, so muscle is paralyzed in depolarized state. Now the stimulators, it comes in two forms. First one is anticholinesterase. Drugs like neostigmine, DFP, it inactivates acetylcholinesterase itself, so massive acetylcholine built up. And the second one is acetylcholine-like action, nicotinic, methacholine. It destroyed very slowly, so that result in spasm. One clinically important part is lethal poison alert by DFP because it causes death via severe laryngeal spasm. So remember, blockers stop, stimulators boost. Simple. Now, one Viva question. Which drug is used in myasthenia gravis? Answer is neostigmine. This is the page that you should revise just before entering the examination hall. Let's answer rapid fire. First one, where the acetylcholine is made? In a mitochondria presynaptic terminal. How much acetylcholine present in one quantum? About 10,000 molecules present in one quantum. What is the absolute trigger for exocytosis? It is a calcium influx. What destroyed acetylcholine? Acetylcholinesterase in less than 1 millisecond. Now just have a drug quick match. Curare, they block the receptors. Botulinum, they block the release. DFP, it kills acetylcholinesterase and produces laryngeal spasm. Now have a pathology cheat code. Myasthenia gravis, they produces antibodies against receptors. Lambert-Eaton syndrome, they produces antibodies against calcium channels. Remember, end plate potential is non-propagative, but when it reaches threshold of minus 60 millivolts, it produces an action potential. So remember this complete sequence. Action potential when it reaches the nerve causes opening of calcium channels. Calcium influx causes acetylcholine exocytosis, which act on receptor opening sodium ions and causes end plate potential. When it reaches a threshold, muscle action potential followed by contraction. And this acetylcholine is finally removed by acetylcholinesterase in less than 1 millisecond. If you can recall this one flow chart, you can answer almost every university question on neuromuscular transmission. If this notebook helps simplify neuromuscular transmission, don't just memorize it today. Revise it again tomorrow for long-term retention. And if you find this memory trick useful, like the video and share it with your MBBS friends. On Physio with New, every physiology topic comes in a complete learning series. Main video, perfect 10 marks university answer, rapid revision, 5-minute exam revision, memory video, flowchart, diagrams, and memory trick. Subscribe now so you never miss the next topic. See you in the next Physio with New video.